Okay, and then after that, so you see that's not a big chapter. There are 1, 2, 3, 7 exercises we're going to do. Now the first one's revision, so we're going to, you don't have to do the homework for 3A because it's revision, so it's very easy. So we're going to cover 3B today, but we'll just go through quickly what 3A is about. Yeah, press record, I did. Okay, good. So first let's go through some terminology. An outcome is a single result of an experiment. And sample space is all the possible outcomes of an experiment. Now, how do I measure probability? We'll use a probability scale from 0 to 1. 0 means it's impossible. 1 means it is certain. Anything in between is probable, okay? Obviously, for a probability that's closer to 1, it's more likely. And for anything less than half, it's unlikely. Okay, so that's half. Okay, good. So there's a formula to calculate the probability, which is this formula here. Number of outcomes favorable to the event divided by the total number of outcomes. Okay, just need to stop down, even though if you probably know it. Okay, all right, let's look at the experiment. We'll roll a die. This is the sample space. What's a sample space? All the possible outcomes. So the possible outcomes are 1, 2, 3, 4, 5, 6. 6 outcomes. So sample space are the actual outcomes. Once you know the sample space, answering the questions are very easy. You write P, 2 means probability of getting a 2. It's 1 in 6 chance that will happen, which is unlikely. And the probability of odd, how many odd numbers are there? There are exactly 3 odd numbers, which is half after you simplify. So make sure you simplify your fraction in probability. And what's probability of more than 2? X more than 2. What do you get? How many numbers are more than 2? 3, 4, 5, 6. How many? 4 out of 6, which you can simplify to be 2/3. These are the things that you've learned since year 7. They are very easy. All right, good. Any question? Let's move on to the next one. Next one is this. Probability. Letter is chosen from the word television. Find the probability the letter is something. How many letters are there? 10 letters. Very good. So probability of V, there are how many V in television? 1, isn't it? So 1 in 10 chance that could happen. How about E? 1/5, 2 10, which is 1/5. Very good. Not an E. Well, to get not E, what you could do, you can use complementary. 1 minus E, which is 1 minus 1/5, which is 4/5. So you can use this formula. Probability of not E is 1 minus probability of E. Okay, that will be very useful. Oh, sorry. Thank you. Nicely spotted. Okay. All right, so we're going to move on. Either an E or a V. So how many E and V or V are there? 3. Very good. Right, so it's a revision, so you don't have to do 3A today because it's very easy. Also, another thing called experimental probability. We'll look at the frequency. So we'll toss 3 coins together. These are the results. Based on the result of the experiment, we can calculate the experimental probability. So the experimental probability of 0 heads are 11 out of 0 head. 11 out of how many altogether? 100 times. So it's 11 over 100, which is 0.11. How about 2 head? 2 head will be 36 out of 100. 0.36. You can answer your answer as a decimal. What if it's less than 2 heads? How many are there? 51. 40 plus 11, so 11 plus 40, which is 51. So you write 0.1551. And at least 1 head means 1 or more, right? At least 1 means 1 or more. So what do? You add them all up. Or you can just go 1 minus probability of no head, which is 1 minus 0.11, which is a 0.89. Any questions? So that's very easy. You don't have to do the exercise if you don't want to, or maybe just do the hard one. And today we're going to go through more serious stuff like 3B. So let's go to 3B. Formal notation for Venn diagrams and two-way tables. Hopefully you remember what they are. Venn's diagram, they have 2 circles or 1 circle and a two-way table. So we have to go through 3 pages. Okay. All right. Let's go through the notation. There's a lot of notation. All right, let's go through this. What's a set? A set is a collection of groups of elements that can include in numbers, letters, or other objects. How do I indicate it is a set? We use a curly bracket. A sample space has a notation as well. You can use S for sample space, or this notation, or this, which I don't know, but just use S for sample space. But all these mean sample space. It's a set of all the possible elements or objects considered in a particular situation. This is also called a universal set. That's why there's a U there, universal set. We also have a name for empty set, a set that contains nothing, and it's called the null set or the empty set. So it's denoted by this notation, a curly brackets with nothing in there, or that symbol there. All right, that symbol means null set, have nothing. And then there's this notation. This means intersection, means elements that belong to both A and B. Union, which look like a U, means elements that belongs either to A or B. Two sets are mutually exclusive if they have nothing in common. So the intersection is an empty set. For the complement of A means not A. So we denote that with an apostrophe, or A prime, like that. That means not A. And to calculate that, probability of not A is probably 1 minus probability of A. A only means it's in A, not in B. So it's written like this. Define all the elements in A, but not in the other set. And NA will be the number of elements in A. Okay, we went through this very quickly, so we're going to apply this in the questions that follow. So let's look at a Venn diagram. So what does it mean for a Venn diagram? So for the first one, let's look at it very carefully. All right, we got the set A, got the set B, right? That's A and B. So the one in the middle, it's called, let's do it in red. The one in the middle is called A intersection B. It belongs to both A and B. And then you have also, what if it's B only? So I do it in green. So B only means that only in B. So it's going to be B intersection with not A, right? That's going B only. Or if you have got A only, there you go, A intersection not B. Get the idea? And of course, there's an outside. What do we call outside? Let's pick a different color, maybe very light blue. All right, outside, like here. So outside you can denote it by, let's use a green pen or black pen. Okay, on the outside you will say A, not in A and not in B, right? Not A and not in B. So they all have the name. Okay, good. Now what does the next one do? This one is not the flag of Japan. It is, even though I could make it look like it. Okay, now what does it mean? This is A, and the one outside of A is not A. So, so if I do this, this is A with a complement. Okay, that means not A. All right, good. So we have all this, so hopefully you are familiar with the notation. Let's look at the two-way table. So you can denote all of this on a two-way table. Okay, so let's look at the two-way table. So the first one is, let's look at the first one, which is going to be in red. So the first one is A and B, right? And what we're going to do is we're going to put an N, because that tells you the number of elements in both A and B, right? N means the number of elements in A and B. So they all have an N. So the next one is an N bracket, N bracket, N bracket. And then we're going to write down this one. The next one is B and A, not A means B only, right? Remember, B only is B and not in A. So you write B, not in A. And this one's A only. So you just go, I did it in blue, right? No, I did it in purple. So this will be A, not in B. And the last one will be the one on the outside, which is in this color here. So this color here are done by A, not in A, and not in B. So basically, all 4 sections, see, all 4 different colors are now in these 4 cells. Okay, so the Venn diagram and the two-way table. Of course, the Venn diagram much clearer. Okay, put it away, Grace. Right, now let's look at the total. So if you add up the total on each row, the first row, you will get total of all the elements in B, and the next total will be all the elements not in B. And then this one, all the total in A, all the total in not in A. And if you add up everything, it's the number of elements in the sample space. This is the sample space, so everything. All right, so it can be very, very detailed. So this is just the summary of all the things we just discussed so far. We're now going to do 3 questions. Example 1, 2, 3. All right. So this topic, even though it can be a bit easier than algebra, but there's a lot of things you need to learn. So make sure to pay careful attention. Let's look at the first example. Consider the given events A and B that involve the numbers taken from the first 10 positive integers. Represent the 2 events on A and B in a Venn diagram. Okay, so let's write them down. There's the A, there's the B, right? All right, so the A's are, now look at which ones are common. The ones are common are 1 and the 3, right? That's the only things that's common that you will put in the middle. All right, good. Anything not in common, so then the other one will be A only, so it will be 2, 4, 5, and 6. And the B only will be 7 and 8. And the sample space is this. That's the sample space. So which numbers we haven't mentioned yet? 9 and 10, so this is outside. Yeah. So the whole sample space is the 10 positive numbers. And then we just have classified them into different categories. Numbers that belongs to A only, numbers belong to both A and B, numbers belong to B only, and numbers that doesn't belong to either A or B. Okay? All right, now once you complete this, doing the next bit is very easy. Let's list the set. So the set containing both A and B, you use a curly bracket for set. The set containing 1 and 3. That's the set, A or 1 or 3. And the set containing A or B will be everything in A or B. So it will be everything here. So it will be 1, 2, 3, 4, 5, 6, 7, 8. So everything. So all means everything, and means common things. And once you list them, calculating the probability are very simple. Let's start with the first one, probability of A. Well, probability of A, there are 2 elements. How many elements? 1, 2, 3, 4, 5, 6. 6 elements in A out of 10 integers, which is 3 out of 5. Yeah. How about the probability of A and B? How many numbers in both A and B? 2, so it'll be 2 out of 10, which is 1/5. And A or B means everything in A or B. And how many elements would that be? Will be 8 out of 10, which is 4/5. Right, so as you can see, once you set up, it's very, very easy. Okay, now we have to look at the word mutually exclusive. What is mutually exclusive? Anyone? We just did that definition. They can't happen at the same time. Very good. Mutually exclusive. So do they have anything in common? They do, isn't it? Because A and B is equal to not an empty set. A and B which have 1 and 3 in it, which is not empty, right? The empty set is this symbol, not empty, right? And it is not empty. So we say, therefore, not mutually, is the empty set is like the 0. That's like the 0 for the empty set, has nothing in it, not mutually exclusive. All right, good. Any question? We'll do another one with a Venn diagram that has more practical use about netball and cricket, both of which are maybe one of your favorite sports. Okay. All right, so we've got 30 students in example 2. Example 2 have 30 students. 12 enjoy cricket, 14 enjoy netball, 6 enjoy both cricket and netball. Okay, so what we do is, we're going to look at these problems, C for cricket, N for netball. So how many people enjoy both? You start with the one both, which is 6. Jasmine, you get 6. 6 that enjoy both. 6 that enjoy both. So how many enjoy cricket only? 6, because 12 minus 6 is 6. How many enjoy netball only? 14 minus 6, which is 8. And then how many doesn't enjoy either? Yes, 10. So you just go 30 minus 6 minus 6 minus 8, which is 10. So there's 10 here. All right, good. So now we're going to answer the question. The question is, state the number of students who enjoy netball only. The symbol for that is N, means number of students, number of elements. Number of elements in N only will be 8, right? Netball only. And number of elements in neither cricket, so not in cricket, C prime, and nor in netball. Actually, I got the wrong symbol. Should be not in cricket and not in netball. Okay, what would that be? Not in cricket, not in netball will be 10. Good. All right. Now, note the difference between when we say the number of students and probability. When it's probability, you have to write it as a fraction. So netball will be 8 out of 30. Oh no, actually wrong. That's netball only. So how many people do netball? 14. And you will get 7 out of 15. And for netball only, which is N only, that will be 8 out of 30, which is 4 out of 15. Okay? And finally, both cricket and netball. How many people do both cricket and netball? 6 out of 30, which is 1/5. Okay, pretty easy. One more page, then we're done. Right. So in this topic, there will be a lot of this Venn diagram notation and two-way table. Oh, yes, we haven't done two-way table. The next one will be involving two-way table. So we're going to translate this into a two-way table. Okay, let's see how that works. So we have a Venn diagram with A and B. The numbers are indicated there. So transfer the information onto a Venn diagram. So you got not in A, B, not in B first. So the first one, A and B, is 1, goes here. And the next one, in B, but not in A, so B only. B only is this. That's B only, B only. So B only is 6. And the A only is 2. And neither in A or B, neither A nor or B, that will be 3. Once you complete them, getting the total are very easy. So 1 plus 6 is 7, 2 plus 3 is 5, and then add vertically 3, 9, and then you just add these two, which is 12 elements altogether. All right, very easy. And then once you get this, we just have to go through all the notation and that based on this example. Okay? Let's go through this. So we start off with the first one. Actually, we could go page width. Okay, good. Number of elements in both A and B will be 1, which is this number here. Not in A and B, must be B only. B only is 6. Not in A, not in B will be A only. A only will be 2. Right, that's A only. A only. And not in A or not in B will be 3. And then how many A's altogether? The number of A's altogether is this number. This is A. Right? This is number of elements in A. So in that case, that's just 3. And the number of elements not in B will be this row, 5. This row, so that's N not in B. So you get 5. And then A or B will be everything in, let me get a highlighter. Actually, this one. Okay, this one here will be everything here. Right? Or basically these ones. Oops. Right? So you just have to add up the numbers, which you will get 1 plus 6 plus 2, 9 numbers. Okay? Yep. What else? And then we'll do some probability question. A and B will be, how many A and B? You just look at this number. It's not done above. The first one, 1 out of 12 altogether. P at not in A, you can just go 1 minus probability of A. Yep. Hi. Yep. You just got one more question to finish. So PA, what's PA? PA is, there how many A? 3. So you just go 1 minus 3 out of 12, which is 9 out of 12. Or you can just use this number here, 9. And the answer will be 3 out of 4. 3 out of 4. And the last one, A not in B, that's A only. A only will be, how many A only? A only will be 2. So it'll be 2 out of 12, which is 1/6. All right, any questions? So by the end of the lesson, you should know what they all mean, the symbol to represent them. Okay, good. You can start the exercise 3B. You don't have to do 3A, but if you want to do 3A, just do a few questions. You can start now. Thank you. You can go to the bathroom.